5.1 rational functions. So here in chapter 5, we're going to look at this thing called the rational function, see what all we can do with it, simplifying, solving, all those wonderful things that we do with it. Okay, so let's start by defining what a rational function is. So in our definitions, here, number one, rational function. So it is a function, we have that as part of our name, right? That can be written as r of x equals r for rational, p of x divided by q of x. Now p is polynomial, q is also a polynomial, but quotient is kind of what we look at there on those pieces. And we do have to note here though that q of x cannot be 0 because we're dealing with fractions, right? With those. Now, that bottom q of x could be just a number because it's a polynomial. A single number is a polynomial with those. So it could work that way, but typically it's going to have a letter in it for those, okay? But we got to make sure that it's not 0 because we cannot have 0 on the bottom of a fraction, all right? All right, now let's see what we can do with these things. All right, so we're going to simplify here. And typically when we see simplify, we know we're dealing with fractions. We're going to look at reducing the fraction. And that's what our idea is going to be behind a lot of these. All right. So 16p to the third over 24p to the seventh. Now, here in this case, since we're trying to reduce the fraction, we want to look at what can we reduce. Well, numbers out in front, coefficients, we can reduce those. Letters that are the same, we can reduce those as well for those. So let's look at how we're going to do that. So let's kind of break this thing into its sections here because we have just multiplication across here. We have our numbers and then we have our letters. And so we want to look at those individual pieces to work with. And I'm going to go ahead and put a fraction bar there. Probably want to do that just in case we need it. That way we're not confused about where things go later. Now, if we find out we don't need that fraction bar, we'll erase it. That's okay. All right. All right. So 16 and 24, let's reduce those. So they're both divisible by 8. So 16 divided by 8 is 2. 24 divided by 8 is 3. Now let's look at the letters. So we have p to the third over p to the seventh. Now, when we're dividing, we do subtract the powers. But an easy way to know where does that power go? We've got a top and a bottom, right? For these. We find the variable with the biggest power. So in this case, we have p to the seventh and p to the third. 7 is bigger and it's on the bottom. So my result should end up on the bottom of this fraction. Okay? So 7 minus 3 gives me p to the fourth. Well, there's nothing else there. This does not reduce anymore. And so there is our result. Okay? So being able to break it down helps us see those things. And let's look at a little bit different style. So 12x minus 15 divided by 21. Now, because of that minus sign, we can't go boxing things off here. All right? We got to think about what's going on. Anytime that we have a plus or minus, anything that has that plus or minus with it is a one big piece. So in order to reduce that thing, it's an all or nothing when it comes to adding and subtracting within those, okay? So in order to just right now reduce this, it has to be something on the bottom with a 12x minus 15. We don't have that. Now, because we don't have that, we need to look and see, can we factor? So that's where all the concepts in chapter 4 come into place. So we need to be able to factor those, all right? So let's look here on the top and see. So we look for our greatest common factor there, and we see that there is a 3 in common. And so I divide those by 3, I'm going to get 4x minus 5. And it's still 21 on the bottom. Okay? Well, now because I've taken that 3 out, it's 3 times something. I can look at that 3 and 21 and see if I can reduce those. And I can divide both of those things by 3, okay? So if I divide 3 by 3, I get 1. If I divide 21 by 3, I get 7. Well, I don't need a coefficient of 1, and so that top becomes 4x minus 5, and the bottom is 7. There's nothing else to factor out of the top. These are not the same, so that is my results. Okay, so always remember, if I have a plus or minus, whatever is being added or subtracted is an all or nothing piece. And we can eliminate, but it's got to be the whole thing for that, okay? All right, here I've got 4y minus 12 divided by 4y plus 12. Now, I know we're tempted right now to start marking things out, but as I just mentioned, you must have everything to be the same if I have a plus or minus. And so in these are not the same because this one's a plus and this was a minus. So that means that I need to look for factoring. So in this case, greatest common factor. Well, on top, we can factor out a 4, get y minus 3. And on the bottom, I can factor out a 4 as well and get y plus 3. So now we can see that those 4s are the same, so they're going to cancel out. But there's nothing else to factor. These are not the same because they have different signs. So we get y minus 3 over y plus 3. And that is my answer, okay, because those are different signs. All right, let's look at our next one. We're just going to keep increasing in size here. And working through them. All right, number 3. So again, we have pluses and minuses. They're not the same, so we need to do some factoring. Okay, so we're going to use our factoring rules. We have x squared minus 16 on top. Well, that's going to give me x plus 4 and x minus 4. All right, so I'll expect you at this point to be able to factor that pretty quickly, okay, for those. If you need to go to the side and work those things out to factor them, whether it's using the guess and check method or whether it's using table method, whatever it is, do that work to the side where it's not part of your problem. It's obviously out of the way for that, okay? But I'm going to expect you to be able to factor those things. On the bottom, I have a trinomial. They're both minus x squared, and it looks like it's going to be 4 and 4 as well. Okay. All right, so now we want to look at the parentheses. Do I have any parentheses that are same on top and bottom? And it's a 1-to-1. So x plus 4, well, there's no x plus 4s on bottom, so it stays. But x minus 4 and x minus 4 cancel out. Now notice I didn't do both of them. It's a 1-to-1 for those. Well, these other two are not the same. We don't need the parentheses anymore because there's nothing else. And so we get x plus 4 over x minus 4 for that problem. So x squared minus 9x plus 8. X squared plus 3x minus 4. So again, we got to factor here. Once we see those pluses and minuses, we have to do that, okay? So let's work through that. All right, so for our top, that's going to look like, again, same sides. And so to get to 9 from 8, we're going to need 8 and 1. And on the bottom here, we're going to have x. This time it's going to be different signs. And so for 4 to get to 3, we're going to need 4 and 1, and specifically plus 4 minus 1. Okay. So if we check that, it does work. Now we can see the x minus 1s are the same. And so we're going to get x minus 8 over x plus 4 for that problem. Okay. So again, as you can see, that factoring piece is very, very important. So hopefully you have this down by now. All right, now we can add a little bit more to that. Here we've got a fraction times another fraction. Okay. Now, the good thing about times and multiplication is we can put those all next to each other. So really nothing is any different. It just means that I'm going to factor more things and I'm going to be eliminating the same exact way. Now, I don't care where it is, as long as it's on top or bottom for those. Okay. So that's what we're going to do here. Let's factor all 4 pieces and then we'll see what we have. All right, so our first one up there, we have x plus 4, x minus 4. Here on the bottom, x squared. I'm going to go ahead and write that as x times x. I have a hunch that I may need to do that. If I don't, I can always put it back together as x squared. It's not a problem. Times. Well, up here, I see there's an x in common. So x and x minus 4. And then over here, we have 2 parentheses, different signs. So it looks like we're going to get x plus 3 and x minus 4. Again, if you need help with those, you should be able to factor that by now. So make sure you're watching out for that. Okay. All right, so let's go through. I'm going to use the top and I'm going to see, do I have that on bottom? If I do, then I'll eliminate it. If I don't, I'll keep it. So on top there, we've got an x plus 4, but nothing else. I have an x minus 4 here and an x minus 4 there. I have an x here and I have an x over there. I have an x minus 4, but I do not have any other x minus 4s, so it stays. And that's all we have on top. So we don't even need to look at the bottom because it has to be both top and bottom. All right, so we've just rewrite it. We don't need to multiply anything back out. So what I have left on top is an x plus 4 and an x minus 4. And then on bottom, I have an x and an x plus 3. And again, I don't need to multiply that out. Go ahead and leave it, okay? But we've simplified it as much as we can. All right, so let's try another one of those. Y squared minus 16. Just picked a lot of problems that had the minus 16 today. All right. So here again, we need to factor just like we did in the previous problem. So we're going to get y plus 4, y minus 4. And on the bottom, it looks like there's a 2 in common. So y plus 3. Now these, there's nothing in common. So I'm going to put them in parentheses just so it all looks the same. You don't have to do that, but it just may help identify things so that you know it goes together. All right, so I've got a y plus 4, there's not one on bottom. Y minus 4 and y minus 4, and y plus 3 and y plus 3. So all I'm left with is a y plus 4 on top, so I don't need the parentheses, and a 2 on bottom. Okay. Now, because this is all one piece, that 2 cannot go into the 4. So that is my final answer. Let's do one more. So x squared minus 9, 2x plus 4 divided by x plus 3 over x plus 2. Now, we looked at multiplication. Now we're looking at division. The good thing with dividing fractions is we can actually turn it into multiplication. So that should be our first step. We keep our first fraction, we change the multiplication, and flip our second fraction. So let's do that. So I'm going to go ahead and just do that as is, so I don't make any mistakes. You can factor and flip at the same time. I'll probably do that in the future. But all I changed this to multiplication and flipped that second fraction. So now let's factor. So I get x plus 3, x minus 3. I can take a 2 out of that one. And then we have x plus 2 over x plus 3. So again, we can see the x plus 3 on top and bottom, the x plus 2 on top and bottom, and I'm left with x minus 3 divided by 2 for my answer. Okay. So those are the things that you're going to be looking for here in 5.1. We're trying to simplify and work through those. Again, if you have not gotten that factoring down, you can see it already. This whole chapter deals with having to be able to factor. So if you can't factor from chapter 4, you're going to have to get caught up with that so that in chapter 5, you can do that as well. Okay? All right, so good luck on that.